So today we will learn a new figure, and that is the frustum. So here is a cone. This is an entire cone, and we learnt about the surface area of the cone, the volume of the cone. But in this case now we are going to cut the cone along a plane that is parallel. So at this point we will cut the cone along this plane. See this plane here, a plane that is parallel to its base. So once we cut the cone, now in the next case we get two parts. One is this one on the top, the cone that is cut out, and we're going to cut this out, and then we have this part which remains, the two parts. This lower part which remains is called the frustum, and here it is drawn again. It's called a frustum. Okay, so how do we get a frustum? We have a cone, and the cone is cut out by a plane parallel to its base, and we get a frustum. Now certain shapes of frustums are like that of a glass. Have you seen a water glass? Is in the shape of a frustum. Or we could have a bucket, also is in the shape of a frustum, a bucket that we use. We have the Turkish cap, which we will learn about. Is also this cap that they use is also in the form of a frustum. We'll now learn the volume of the frustum, the surface area of the frustum. So if you look at the frustum, it has got two circular edges. One is up here. This is one circular surface. This is the top circular surface, and that circular surface will have its radius. We'll call this radius as r, small r. And then below we have another circular surface which is a little larger than the top one. And this circular surface we'll call the radius in this, it's larger, and we will call it, this is the center, so this radius will be the capital R. And here we see the height of the frustum is given to us, this h. This h is the height of the frustum. So when we are dealing with a frustum, we always have two radius. The smaller radius here, in this case this one, the smaller r, and we have the larger r, and this is the height of the frustum. And there's another important thing called the slant height of the frustum. We call it L. So L is called the slant height. Just like a cone had the slant height, the frustum too has a slant height. This is the slant height. This h is a central height, or it is just called as height of the frustum. Now the volume of the frustum is given by the formula. So here's the volume of the frustum, 1 by 3 pi, we have h, and then we have r square, that is the smaller r, plus this r, the capital R, plus r1 and r into r. This is the volume of the frustum. Now we have the CSA of the frustum. Now the CSA is this region, the CSA. And we will see what's the formula for the CSA of the frustum. So we'll just write CSA of frustum. It is pi L, which is a slant height, this slant height, L, R plus R, CSA of the curved surface area of this frustum. And now if you want to find the TSA of the frustum, it will be the CSA plus this orange circle, right, the top one, plus we have the blue bottom of it, this here, this one, the blue, that will be the TSA, the total surface area. It has got three surfaces. We'll mark the surface. This is one surface, this is the second surface, and this is the third surface. So this is the first surface, this is the second surface, and this is the third surface, which means it is pi L r plus r plus this is pi r square and pi r square. Both these are circles. So this is the TSA. There's no need of learning the TSA. You just learn the CSA. The TSA will come automatically. But an important point now is to learn how to find the L of the slant height of the frustum. Now to find the slant height of the frustum, let us mark the radius. Here is the small r, and then we have here the capital R. Now remember, we want to find the L. We want to find this L of the frustum, this part. This we want to find, L of the frustum. Okay, that is our main objective. So what I'm going to do now, I'm just going to join this end to this end. See, I'm just going to join this here like this. Right, and you'll agree this is the h of the height of the frustum. Now what would this be? This little area, this one. I will mark it another color so you can see it properly. What would this be? How much would this red part be? We know this is h, we know this is L in this triangle. This is a right angle triangle we have now here, and we're going to deal with this right angle triangle to give us the L. So let us see what will this be. This is important, this part. We've seen from here to here is R, but from here to here is small r. So this segment will be R, capital R, minus small r. Fine. So in this triangle, so again we'll just focus on this gray triangle. This is a right angle triangle here that we have, and in this right angle triangle, this is our L here, this is our H here, and this is R minus R. The 90 degrees is at this point, so we use Pythagoras theorem, and we will write L square, we'll write it here, L square equal to H square plus R minus R the whole square. So your L slant height will be under root of H square plus R minus R the whole square. So you'll have to learn this. It is nothing but just Pythagoras theorem used in that little triangle.